Alright, let's do another problem from section 1.3. So this is still a focal date problem. It's still a equation of value problem, but this time we don't know the payments, but we know how much we've taken out. And also notice that we have unequal time here. Later we're going to deal with equal time when we make regular payments. Those are called annuities. We'll deal with that when we get to chapter 3, and we have compound interest. But for now, it's going to work just a little bit differently, so we need to kind of understand how this functions. So first thing I'm going to do is I'm going to change this one to be, instead of 10 months, we're going to use 2 years, and instead of 5 months, we're going to use 6 months, just so you have a good example of a mix of something that uses full years and partial years. We haven't really done as many problems with a full year, so this is a little bit different than what I have in the notes, but literally all we're changing is that. It's going to work the same way, we'll just get different numbers if we were to work it with 5 months and 10 months. So let's set up our timeline. First we're going to do the now. So again, I'm going to color code these just to help you understand what's going on. And we know it goes at the beginning because we have that keyword of is borrowed. So the amount is borrowed. That's how we know it's the now piece. And then we're told it's borrowed for 2 years. So we know that this is 2 years. We also know our interest rate is 16.5% or 0.165, which is a higher interest rate, but you never know with what's going on. So that it could really be anything. And then we're told that 2 equal payments are made. So we're going to do one of the payments, 2 equal payments. We'll do this one. The first payment we'll do in orange, and then and that's at 6 months. And then the other payment is made at that 2-year mark. So we'll do that one in the 6 months, and we'll do that one in purple. So 2 year. So that's our other X. So it's still 2 X's. They're the same payment. They're 2 unknowns, and we know that they're the same because we're told this right here again, the idea of 2 equal payments. So that means that they're the same value. So no matter what, the X's, they're both going to be an X. Okay, so let's set up our timeline because we have all of our information. So in the previous problem, we had talked about how when we move backward and forward, we do different things. So if we go backward, either way, we're looking at P versus S. So if we go backwards, that means we're moving from S to P. So we use P equals S divided by 1 plus RT. And if we move forward, we go this way, then we're going to use S equals P times 1 plus RT. So that's the big idea, just to kind of recall our 2 equations here. Alright, let's go ahead and jump in to this problem. Alright, so we have our 3200, and I again am just going to set that up on its own. So we're going to kind of have a loan is equal to the payments, which is pretty easy to remember. And then we have X, and this is going to be moved backwards 6 months. So that would be 6/12 of a year for our T. So 1 plus 0.165 times 6/12. So that's our first piece in our equation. And then the second piece in our equation, again, we're going to have that division, and it's going all the way back. So it's going to be 2 years. So that means T is just 2, which is why it's a little bit different because it's a full year. We don't have to use a fraction. Before we can do that in a calculator, since we have 2 X's, we have to figure out what the coefficient is in X. So what we're going to do is we're going to factor out the X. So this is going to become 3200 equals X, and then this is really X times 1. So we get 1 over 1 plus 0.165 times 6/12. And again, you can reduce that, but you don't have to. Let the calculator handle it. And then this is going to be our coefficient. So it's a little bit different than the previous problem because we have that added step of factoring the X's, because we want one copy of X, we don't want it on both sides. So let's find the coefficient on the calculator. Alright, so now that we have our calculators pulled up, we're going to find again this big coefficient. So I'm going to enter that all in as one thing, I'm going to save it, and then I'm going to do my 3200 divided by that value without rounding. Okay, so first we have to find what the value is. So we're going to do 1 divided by, and then parentheses to do our denominator, 1 plus 0.165 times 6 over 12, or half a year. And then we're going to add that to our other piece, so that was just this fraction, 1 over, and then parentheses for my denominator, 1 plus 0.165 times 2. So it's going to look like this. So that means our coefficient is going to be 1.675. And it's a big ugly decimal that's going to repeat, but again, we're not going to round that. We're going to store it in our memory. And then we're going to take 3,200 and divide that by that value. Again, not rounded. We don't round coefficients, we round monetary values. And we get, depending on your machine, you could just do divide by answers. The scientific calculators do have that capability, but the computer one does not. So that's a separate button. Usually you have to use the second and whatever. And you can always work on me with that to kind of help you understand how that works. YouTube videos are good too. Our X was 1,909 and 60, and again we want to check our piece here. So we have 0.687, so we want to look at the 8 and figure out if we have to round it. 7 is bigger than 5, so we round up. So there's our payment for using a focal date of now. Go ahead and try to set up the equation for the focal date of 2 years from now. Now that you've had a chance to set it up with your focal date, let's go ahead and take a look at that. So we're going to do the same process, but now we're using a focal date of 2 years from now. So that means 3,200 is going to get moved down 2 full years. So our t is going to be 2. So 3,200 times 1 plus 0.165 times 2. And that's going to be equal to each of those payments. Now our payment for the 6-month piece here, we're moving from 6 months to 2 years, so that means our t is going to be 18 months or 1.5 years, or you could use 18 over 12 years. Any of those would be fine. It is absolutely personal preference. So our equation would be x times parenthesis 1 plus 0.165 times, and then I'm just going to do months just to be consistent with what we've been doing in previous problems. So 18 over 12, and then you have to end that parenthesis, and then our other payment is already where it needs to be without any movement, so we just add x to it. So this is what your equation should look like. Hopefully you did it. If not, talk to me and I will help you get there. Now that we have this, we're going to go ahead and factor out the coefficient. So we're doing the same process. We're going to pull out the x on the side that has the x's. So we get 1 plus 0.165 times 18 over 12 from the first piece. And then we get a 1 from our other piece because we only have 1x. So this is really x times 1. And if you need to add in the plus 1, I wouldn't worry about that. Now, let's go ahead and switch over to our calculator so we can do some of these calculations. Okay, so before we finish our equation on this side, let's find out what this value is. So we're going to do 3,200 times, and then parenthesis 1 plus 0.165 times 2. To get our future value there, so we get $4,256. And then over here we need to find what that coefficient is. So go ahead and try to do that in your calculator. So we get 1 plus 0.0165 times 18 divided by 12. Plus another 1, so our coefficient here is 2.2475. And again, I'm going to put that in my memory to store it. So just checking my memory here. Yep, that's the value I want. So I'm going to clear that out and put in our answer. So we get 4,256 divided by that number. In this case, it ends up being a nice number, so we don't necessarily have to use the memory store, but again, it's a really nice feature to have just so we don't have to worry about it. So we get x equals $1,893.66, because again, that 9 tells us to round the 5 up. So again, comparing these like we saw before, they are pretty close, but here they're almost $15, almost $20 difference. So again, there is a difference in using the focal dates, and your problem will be very specific as to when to use the focal date in these type of problems. In the next section, in section 1.4, we look at doing them with specific ways to make partial payments. So paying as you go, and then how that affects your mortgage or other